Okay, slides 42 and 43. And 42 is similar to the one that we did earlier. They're giving you a 50-50 buffer. So at that point, we know pKb is equal to pOH, or pKa is equal to pH. We're dealing with a magnesium hydroxide system, so I wrote out that the magnesium hydroxide breaks up into magnesium 2 ions. Well, nobody calls it magnesium 2, it's just magnesium, plus 2 moles of hydroxide. And I wrote out the KSP, magnesium 2 plus times hydroxide squared. All right, so pKb is equal to pOH, and if we do the inverse log, then Kb is equal to OH minus concentration. So we can take a shortcut here since we've already done the last problem that was similar to this. 1.8 times 10 to the minus 5 molar is the concentration on the OH minus. So we could just substitute that in and solve for the magnesium. So magnesium 2 plus is equal to KSP over OH minus squared. And that's going to be 1.5 times 10 to the minus 11 over 1.8 times 10 to the minus 5 squared. And this comes out to be some ungodly number, which I hope is 4.6 times 10 to the minus 2. 1.5 exponential negative 11 divided by 1.8 exponential negative 5. Let's square that. And we get 0.046, which is 4.6 times 10 to the minus 2. All right, good for us. So far, so good. All right, this one I put in here just because it was numerically annoying. And at the time, I thought that was fun. I didn't realize 20 years later I would no longer think it was fun. But anyway, we have a complex being formed. So this is a formation reaction. And they tell you the complex being formed is iron. Actually, it's called hexocyano iron 2. And so hexocyano, so 6 Cn minuses, and iron is iron 2 plus. Now you get that from the fact that it has an overall charge of negative 4, and cyanide is Cn with a minus charge. So if the total charge on the cyanide is negative 6, then that means that the charge on the iron has to be positive 2, so that the total charge is negative 4. So that's how I came up with that equation. Iron 2 plus 6 moles cyanide produces hexacyano iron 2. And the Kf for that is given at 1 times 10 to the 37th. And then we do products over reactants. All right, from here, now it's just annoying algebra. We have a reaction that is shifting really far to the right. So, and will there be some iron 2 plus left over? And the answer is yeah, but a tiny, tiny amount. So if we look at the reverse reaction for this, the K for it would be the inverse of 1 times 10 to the 37th, which is 1 times 10 to the negative 37th. So we're not losing much hexacyano iron complex. So I'm just going to consider the concentration of that to be equal to the 0.1 molar that they gave me. So I'm going to write that in, 0.1 molar. And if iron is X, that means cyanide is 6X. So I'm going to substitute that in. X times 6X raised to the 6th. All right, what fun. So this is going to be 0.1 over, let's see, 6 raised to the 6th is 46,656. X to the 6th times X is X to the 7th. So we get 46,656 X to the 7th. All right, so now we can solve for X. 46,656 X to the 7th over 0.1 is equal to 1 over Kf, which is 1 times 10 to the 37th. So this is going to be 46,656 x to the 7th is equal to 1 times 10 to the minus 38th. Now I can solve for x. So I take 1 exponential negative 38 and I divide that by 46,656. And that means I have to take the 7th root of 2 times 10 to the minus 43. So let's do that. 2 exponential negative 43, and we're going to raise that to the 1/7 power. And I get 7.9 times 10 to the minus 7. And they went 1 sig fig, so it's 8 times 10 to the minus 7 molar. And X is equal to the iron 2 plus concentration. And that's it. All right. Thank you very much.